After this, we'll see something. Suppose if I tell you that this is our vector A and this one is our vector B. And if angle between A and B given to us as suppose theta, and I ask you that what will be the angle between the vector which is A minus B. So if I write minus B or if somewhere written minus B, it means we are talking about a vector, a totally new vector whose magnitude is same as B, but direction opposite to B. So in this figure, totally you can tell the angle that is between A and B, it is this one. Then what will be the angle between A and minus B? So first I will find the vector minus B. For that, I will draw an arrow whose length is same as the length of the arrow P, but direction opposite to the arrow P. And I can draw that arrow anywhere. Maybe I can draw it here. And for keeping A and B and A and minus B in the tells together arrangement, I can shift vector A parallel to itself and I will draw in here. So this is also our vector A, but this one will be minus B. So totally you can check out the angle between A and minus B. It's going to be this one. And that angle is pi minus theta. Since what I have done is this black arrow B and this arrow of minus B are drawn on the same line. So that angle, we call it as theta. This one will be pi minus theta. But pi minus theta what? Pi minus theta not in clockwise, anti-clockwise manner. It's in clockwise manner, no? So the given figure, I have got angle between A and B is theta, which is anti-clockwise. So if angle between vector A and B is equal to theta, then what we find is the angle between A and minus B is equal to minus of pi minus theta. So maybe I can write down like this also, pi minus theta, but in clockwise sense. And if that is theta in anti-clockwise sense, this one is pi minus theta in clockwise sense. I hope this thing is clear to all of you. And next I'm going to do something in which this formula of trigonometry will be used. Cos pi minus x is equal to how much? Minus cos x. And one more I will use, that is sin pi minus x. That's going to be equal to plus sin x. Cos of minus x is equal to cos x. Sin of minus x is equal to minus sin x. And maybe this one might be tan of minus x is equal to minus tan x. I hope these formulas are clear to all of you. Okay, I can take a new page. Next we'll be doing is what to do if I have to find A minus B. So A minus B is not really A minus B. It is adding A and another vector which is minus B. And this minus B vector is having same length as that of the vector which is B. So if I ask you find out what will be the magnitude of the sum of the vector A and minus B will be. I hope you're getting it. We are not doing is subtracting B from A. It is same as adding A and some another vector. Just that vector name is minus B. So what we do to find the modulus of sum of two vectors, same thing we are going to do here as well. A square plus B square. So A square plus modulus of B. So instead of that, I'll write modulus of minus B square twice of modulus of A, modulus of minus B, and cos of the angle between A and minus B. No? So in here, what we are going to use the angle between not A and B, but the vectors that we are adding here is A and minus B. Now, in case if angle between A and B given to us, not the angle between A and minus B, then what we do is we will find what is the angle between A and minus B is. So if angle between A and B is given as theta,
So can you 1 minute show the previous page?
mm,
Thank you. Thank you, sir.
okay, just a second. If I can you hear the audio now? You can hear me now.
Yes, sir.
But
Yes, sir.
now if I connect, it is better. Now it is same or different?
Same, sir.
Same, sir.
Same only. Just a moment. Now the sound is better or not?
Yes, sir.
Better.
It's better, no? Than what it was earlier, correct? No? Okay then. Okay, I can take a new page. Okay, I can take a new page. In case if you want me to go back to that page, I'll do that. If angle between A and B theta, then angle between A and minus B will be minus of pi minus theta. So what will be cos of minus of pi minus theta will be, so minus given to cos function, nothing is going to happen. It's going to be same as plus only, no? Cos pi minus theta is going to be minus cos theta. So due to which this result will become, and the modulus of A, sorry, modulus of minus B or B, both are same thing only. So instead of modulus of minus B, I will write modulus of P only. This will become A squared plus B squared minus 2AB cos theta. So what is the theta in here is? It is the angle between A and B, not the angle between A and B. And if I have to find that thing also, the angle made by the resultant of A and minus B with the vector A, and maybe I'll write down as tan phi dash. So that will be equal to minus B sine of minus of pi minus theta by modulus of A plus modulus of minus B into cos of minus of pi minus theta. So sine of minus of something will be minus of that thing. Sine of pi minus theta is minus of sine pi minus theta, but sine pi minus theta is sine theta, so that will be minus sine theta. So this thing becomes, and minus b modulus is same as b modulus, so b into minus sine theta divided by modulus of a minus b cos theta. So this is the result of tan phi dash b. Okay, I can take a new page.
Yes, sir.
Okay. Suppose PQ is our vector A and PS is our vector B. So PS arrow we are using to represent vector B. So the QR arrow will be representing B only. But here I have drawn arrow here as RQ. So RQ arrow is of same length as QR arrow, but in direction opposite to it. So PS arrow I'm using to represent B. So whether I use PS or QR, both are going to be correct representation of vector B. But what will be RQ then? RQ will be minus B, no? So RQ minus B and PQ and SR both are correct representation of A. So this is our A. And already we know in such parallelogram PQRS in which PQPS represents vector A and B, then the sum of these two is given by this diagonal. Correct. Now you concentrate on this side now, SR and RQ. So what is SR and RQ are vector A and minus B. And SR ending at R, RQ starting at R. And they are totally in the tailhead arrangement. So adding them, raining outside. Adding them, we are going to get SQ. SR is vector A and RQ is vector B. So it means A minus B is going to be given by the diagonal SQ. So already we knew this diagonal is giving us the resultant of A and B. Now we know that this diagonal, the another one SQ, is going to give us the resultant of A and minus B. Okay. I hope this point is clear to everyone.
Yes, sir.
Okay then. The next thing that we are going to see is unit vectors. A vector whose length or magnitude is 1, such vector we call it as a unit vector. The symbol we use, like suppose if I have a vector A, which is a unit vector, then the symbol we use for such vector is A having power, not power, A with this caret symbol on its head and pronounced as A cap. So length of such vector is equal to 1. The reason we use this unit vector is for telling directions. Okay, it's raining, man, I see. Okay. Now, suppose if I have a vector which is of length 1 and in the direction which is plus x, we call it as I cap or x cap. Unit vector which is in the direction y is called as j cap, or we use the symbol y cap. The vector whose length is 1 or unit vector along the plus z direction, we use the symbol k cap or maybe sometimes j cap. So there's one more way to write a vector. Suppose if I have vector A it can be reported like this: magnitude of the vector A into A cap, which is the unit vector in the direction of vector A. And that is the magnitude of the vector A. For example, maybe I'll take an example. I suppose if I write vector A is equal to 3 I cap, suppose. So this I cap is telling me the direction that it is along plus x-axis, and 3 is telling me that how much the magnitude this guy has. So any vector A can be written like this: magnitude of the vector A into unit vector in his direction. So if I want to find out this A cap guy, for that I can do this thing. You will be dividing the vector A with the length of the vector A. I hope this thing is clear to all of you.
Yes, sir.
Okay, then. Next thing is component of a vector in a direction. For that, I will take an example. Suppose this is our eastward direction, or maybe this is our x direction, and this is our north or maybe y direction. And here is a vector A, which is of length 10 kilometers at an angle of 53 degrees from eastward direction. So in doing this vector A of 10 kilometers in northeast direction, and not like northeast, it is 53 degree due north of east. So doing such vector, how much we have done traveling along x, or how much we have done traveling along y, if that is to be found, what to do? I hope you got my question. That if there's a particle which travels along this red arrow by 10 kilometers at an angle of 53 degrees from the eastward direction, then in this much traveling, how much he has traveled along east or north, how to find it out. So maybe I will consider calling this angle as theta, which is 53 degrees. Suppose I want to find how much we have done along x or eastward direction. So what really component of a vector along a direction means? How to find that is one thing, but what is the meaning of this thing is that it gives us how effectively the vector, or maybe it gives us the effect of the vector in that direction. So due to doing this vector A, how much we have traveled along east will be the component of A along east. So to find the component of a vector along some direction, what we do, so this is the direction, the x direction along which I have to find the component. So from the tip of the arrow of that vector, we will drop a perpendicular like that. and whatever the length of the base will be, that much will be the component of the vector along that direction. So maybe I will name this triangle as P, Q, and R. So PR arrow is representing the vector A. So PQ arrow will be representing the component of the vector A along eastward direction. So in that triangle PQR, I can write cos theta to be equal to PQ by PR. So what will be PQ will be PR cos theta. PR is of same length as the vector A, so A into cos theta. So component of vector A along some direction is going to be the vector A into cos theta, where theta is the angle made with the direction. Obviously, what direction? The one along which I have to figure out the component of the vector A. So in this case, our vector A is of length 10 and theta is 53. So 10 into cos 53 is 3 by 5. So that becomes 6 units. It means in doing 10 in that manner at an angle of 53 degree from east, we have traveled 6 kilometers or 6 units along eastward direction. So whenever we have to find component of any vector along some any direction, like suppose I have to find component of this vector which is A along some direction which is this one, then every time we find what angle the vector A has got with that direction. So the component along that direction will be equal to A cos theta, where theta is the angle made with the direction. Or basically what we do, we drop a perpendicular from the tip of the arrow of A, and we find what is the base of the triangle will be, and that will be the component of the vector along that direction. I hope these all things are clear to all of you. So what really what really you have to do to find component of a vector along some direction? So you must be knowing what angle the vector is making from that direction. So the vector into cos of that angle will be the component. Okay, I can take a new page.
Yes, sir.
Okay. So this is our x and this is our y. And I give you a vector, which is this one. Maybe A, whose length is 20. And it is making an angle of 53 degrees with negative x. And job here is to find the x component. So what to do? So you can still use the same result. But be careful, we are supposed to find the component along x. So for that purpose, I will need the angle made by the vector with the x direction. and that angle is 180 minus 53. So we must be using this angle. So for finding x component, again we'll be doing the same thing. A cos 180 minus 53, and cos 180 minus x is what? Minus cos x. So the answer will be minus of a cos 53.
Forward.
So yeah, so it's going to be minus 20 into 3 by 5, and that will become how much? Minus 12. So here the x component is coming negative. It means the vector, because of doing this vector a, we will be traveling in the direction of minus x, not plus x. No, that is what minus sign is giving us the message here. So it's like if I tell you the loss is like profit is minus 5, means what you get? It is a loss of 5. No, same way, I'm telling you the x component is minus 12. It means if this vector is of 20 kilometers, and maybe this is our east, and this is our north, and this is our south. So in traveling these 20 kilometers at that in that manner, we have done 12 kilometers along south. But I'm not asking you how much we have done along south. I'm asking you how much we have done along. Sorry, what south man is east, north, west, no. So in doing this 20 kilometers in northwest direction, we have traveled 12 kilometers along west. But when I ask you find the component along east and I get negative, it means a negative sign just telling us we have done opposite to east or opposite to x here. So there can be some other way also. Suppose you don't know this formula that cos 180 minus theta is, or cos 180 minus x is minus cos x. Then what you do? You find the minus x component of this vector. So for finding minus x component, not issue at all, because this vector A is making some acute angle with minus x direction. So sometime you can do this also. You can find the minus x component, and minus x component, for that I don't need to know that formula. So it will be a cos 53. So a cos 53 will be 20 into 3 by 5, that is coming 12. So I hope you got the point now, that if minus x component is 12, then automatically you can tell what will be x component. So minus x component is coming out to be 12. It means x component will be minus 12. So in case if you don't know how to find the angle which is 180 minus 53, then you have a choice like that. Okay, I can take a new page.
Yes.
Okay, then. Next is how to write a vector in terms of its Cartesian components. So maybe I will take the example first of something in 2D. So we have a vector A which is making an angle theta with positive x. Now if I ask you find the component of this vector along x direction, then I will be using this angle which is theta. So x component it is going to have, and that x component will be of length same as PQ, no? And that will be A cos theta x, which is theta here. So maybe I will give some numerical values also for this then. And this is our 53 degrees, suppose. So in order to do this vector PR, we will end up doing PQ amount along X. Now if I ask you, in doing this vector A, how much we have done along Y? So to find the component of this vector along Y, I will need whatever angle it is making with the Y direction. So Y component will be, or maybe if I drop a perpendicular to the y-axis from the tip of this vector PR, then this PS is going to be the length of PS is going to be the component of our vector PR along y direction, no? Because in doing PR, how much length we have done along our y direction, PS length. Or maybe even I can say in doing PR, the amount that we have traveled in the y direction is equal to QR. So whether you consider QR or PR, both are of same length, no? So y component will be vector A into cos of the angle he is having with y direction. Because to find component, we need just the angle between the vector and that direction. And in here, if theta x I write down as theta, then what theta y will be? Pi by 2 minus theta, no? Because you can totally see this angle theta x and this angle theta y, they add up to 90. So whatever way you find out this thing, that will be a cos of pi by 2 minus theta. That will be a sine theta. Okay, that's a formula again. Cos pi by 2 minus theta is equal to sine theta. Now you check out one thing that has to do with triangle law. PQ and QR. PQ and QR, if I add, it is going to give us PR, no? And PR is our vector A. So vector A I can write down as PQ plus QR. Now check out this PQ vector. That is basically the X component of our vector A. And you check out it is of what magnitude? It is of magnitude A cos theta. And since it is the X component, I will write his name as AX. And what is the direction he is along? Plus x-axis. And for that, we use the unit vector I cap. No? So if I write PQ vector to be equal to AX I cap, it is totally fine thing to do. Same way you check out QR. QR guy is of magnitude how much? Whatever is the Y component, which I will be writing it down as AY. Its magnitude AY. And its direction is along y direction. So the unit vector along him is j cap. So QR I can write down as AY into j cap. So our vector A, I can report him like that. AX I cap plus AY j cap. Correct or not?
So if I tell you vector A is ax I cap ay j cap, where ax ay are the components, what you can do, you can use these components to find the length of that vector also. You see, ax square plus ay square is going to become equal to how much? A square cos square theta, and ay is how much? A square sine square theta, and that will give us a square. So this is what we can do to write a vector in terms of its Cartesian components in 2D, no? And if I know the vector in terms of these components, other uses are also there. I want to find what angle it is making from the positive x direction. That too we can do. Okay. Copy this thing. Or maybe next page I will tell directly in 3D one.
Sir, how will you write a square plus ay square? Sir? A square cos square theta a square sin square.
And that is what will happen. Just a moment. Let me write it nicely. See, ax is a cos theta x, correct?
Yes, sir.
Ay is a cos theta y, correct? No.
Oh, yes, sir.
So let me tell you that thing. Before that, I can use this thing to figure out cos theta x also. If I can find a from it, no, I can
Yes,
use
sir.
it to find cos theta y also. If I can find the length of the vector a. But what is theta x? I called it as theta. Then theta y will be pi by 2 minus theta, no?
Yes, sir.
So if I add up ax square plus ay square, you will have a square cos square theta plus a square sine square theta. And what it is going to become? 1, no?
Yes, sir.
So it means if I square up and add the components, it is going to give us a square. So I can find out the length of the vector a using it. That will be ax square plus ay square, correct? No? So,
Okay, sir.
so I did cos theta y only, but here theta y will be pi by 2 minus theta. So it became sine theta. That is a formula you should know. Cos 90 minus theta is sine theta. And you know even cos 60 is it not equal to sine 30. So it is that thing. Okay, I hope this thing is clear to all of you. And also you don't have to use these things. What is the length PQ is? AX, I'm calling it as. And what is the length QR is? AY. So I can use Pythagoras also or not. What is our vector PR? K is, it is the arrow PR. So what is the length of the arrow PR is? Directly you can tell ax square plus ay square root over, no? Not clear, no? This thing clear to all of you, no?
Yes, sir. Yes, sir.
Okay then. Mm. Now here I have a vector A which is making theta x with positive x, theta y with positive y, and theta z with positive z direction. Then that vector A is going to be having x component to be equal to a cos theta x, y component a cos theta y, And its z component likewise will be a cos theta z. So the vector can be written like this also. I'm telling it directly without proving it. So vector A we can write down like this: ax I cap ay j cap plus az k cap. Then if I ask you find the length of this vector, try to prove this thing on your own. Ax square plus ay square plus az square. And if I ask you find the, so it means the moment I give you this vector in terms of its components along x, y, and z, using the components you can figure out the length of that vector. Once you get the length of that vector, I can use it to find out cos theta x. Because cos theta x I can figure out by knowing the x component that we know, the length of the vector that we can find. So cos theta x will be ax by a, cos theta y will be ay by a, cos theta z will be az by a. And these three things together is called as direction cosines. Why? Because theta x, theta y are the angle made with positive x, y, and z. And why we find these angles? To find direction. So these angles are like synonym of directions. So these are also called as direction cosines. And if you add up, square up and add them, you will see it is going to be equal to 0. So cos square theta x plus cos square theta y plus cos square theta z, you add up and check what it is going to come. It is going to become equal to 1. Okay, I hope all of you got this thing. So check out this proof from S.C. Verma or whatever book you have. I can take a new page.
Yes, sir.
Now what we will do, everyone do this question. This is vector A making an angle of length 20, making an angle of 53 degrees. This vector B of length 10 making an angle of 37 degrees. This is vector C, which is 5 root 2 length and making an angle of 45 degrees. And this is vector D, which is of length 2 units along minus y direction. So do one thing, find every vector in terms of their components and then you figure out A plus B plus C plus D. The first job is you find out A, B, C, and D, all of them in terms of their components, or you write them in I cap and J cap form. Everyone do it. I'll give you 2 minutes. In that 2 minutes, I will go and I'll bring coffee. So you try this question in the meantime.
So can you show the previous page for a second?
Okay, then all of you were able to find the component of A, B, and C along
Yes.
X and Y. Okay, now I'll do it fast first. Just check your answer. So vector A is 20. So his X component will be 20 into cos 53. And that will be 20 into 3 by 5, which is how much? 12. His Y component will be 20 cos 37. Because the angle he is having with positive Y is 37. So 20 into 4 by 5. So that is 16. So vector A is going to be 16 I cap. What 16? 12 I cap plus 16 j cap. Now, the vector B has got angle 180 minus 37 from positive x. No? So the x component of vector B will be B cos pi minus 37, and that will be minus cos 37. So minus B cos 37, and that will be 10 into 4 by 5, that is minus 8. Y component of the vector B will be B cos 53, because his angle made from positive Y is 53. So 10 into 3 by 5, so that is 6. So vector B is minus 8 I cap plus 6 j cap. Vector C is making 45 degrees with positive, negative x and negative y, no? So vector C is making how much? So maybe here easy way could be you find the minus x component of the vector C, and then from that you figure out the x component, or else you have to use this all angle. So angle with positive x, positive y is this much. And angle with positive y also we know. So maybe Cx will be vector C into cos. So you see angle it is making from positive x is 180 plus 45. No, I'm not drawing it. You can see it for yourself. And cos pi plus theta is also minus cos theta. So that will give us minus C cos 45. Or else you can do this thing is you find the minus x component of the vector C. So minus x component of vector C will be the angle made by vector C with minus x direction is acute angle 45. So that will be C cos 45. And that will be 5 root 2 into 1 by root 2. And that will become 5. So since his minus x component is 5, so x component of vector C will become minus 5. So, or you can do it like this also. You find whatever angle it is having with positive x, which is 180 plus 45, and cos 180 plus 45 is minus cos 45. Either way, answer coming same. The y component will be C cos. The angle made with positive y is pi minus 45. So that is minus C cos 45. And that will come minus 5. Or again, you can do that thing. It is making how much angle with minus y? This is our minus y. And it is making 45 with minus y. So his minus y component is same as minus x component, which will be 5. Got the point? How come we got the y component as -5? You can hear the noise, no man? -5 I cap, -5 j cap. This was disturbing. What to do? Vector D will be, so vector D easy, it is lying entirely along what direction? -5 direction. So his x component, if I ask you what it will be, 0, because it's not doing anything along x. And his y component will be negative, no, because he is acting along -y. So what will be the answer for D will be -d j cap, -2 j cap, no? Now when I have to add A, B and C, it's easy. A plus B plus C plus D will be, you add all the x components together, 12 -8 -5 I cap. You add all the y components together, 16 plus 6 -5 -2 j cap. And that will give us whatever in terms of components. So just a moment, I'll write down. A plus B plus C plus D equals, and 5 times in a day, they will disturb everyone. 12 -8, it is how much? Minus I cap. And this will be 12 plus 6 -5 -2. So 6 -5, 1, 1 -2, -1. So 15 j cap. So sum of A plus B plus C plus D is equal to minus I cap plus 15 j cap. So it means if I can write vectors in terms of its Cartesian components, I can easily use it to find maybe A plus B plus C plus D. Maybe anything, like even I can ask you find A minus B minus C plus D. So such operations will become very easy, no? I hope whatever we have done on this slide is clear to all of you.
Sir, can you explain how the dx becomes 0, sir?
So which way D is? D is traveling along minus Y.
Yes, sir.
So you're traveling along east only. How much you have traveled along north?
No.
0, correct, no?
It will be 90 degree, no, sir, from the x.
Yeah, so that's what, no? Suppose if I tell you, maybe I will name it as east. No mass, we don't bring mass. Without mass, we have to answer things. This is east, this is north, this is west, and this is south. Now, just you think of vector D, don't think of anyone else. If I do vector D, maybe I travel 2 kilometers along southern direction. So how much I have traveled along east? 0. How much I have traveled along west? 0. How much I have
Sir.
traveled along my north? -2 kilometers. How much I have traveled along, maybe, what to say, perpendicular to the surface? That too 0, correct? So
Yes,
this
sir.
vector is lying entirely in the southern direction or -y direction. So doing that vector will not be making us do anything along x, no? So x component 0. Or you can say, what is the angle this vector D is having with x direction? 90. So component of that vector along x direction will be vector D into cos 90. But what is cos 90 again? 0.
Yes, sir.
Not clear, no?
Okay, sir.
Clear, no? But mass should not be giving us the answer. You can tell, if I travel along -y, how much I have traveled along x due to him? 0. So 0. Clear, no?
Yes. Yes.
Okay.
Sir, if the same d vector is given in the x line, then the y
Then
will be 0.
yeah, correct. Then y will be 0. You're correct.
Thank you, sir.
Okay, now whenever we have vectors given to us in co-initial arrangement, what we do, we use parallelogram law of vector addition. No. So suppose if I tell you we have vectors A and B and they are of equal length, then what is the angle the resultant will be making with each of them will be theta by 2 if the angle between A and B is theta. Can you prove it fast? So we have to construct a parallelogram, but we are doing it, but in our head. And the resultant of this two is given by that diagonal, which is passing through the tail of A and B. So this A plus B, the resultant of A and B, is going to make an angle with vector A, and it is going to make an angle with vector B. So the angle made with vector A and vector B, both are going to be equal if A and B are equal vectors. So maybe you prove it at home. If A and B are equal, then the angle made with vector A will be theta by 2, and angle made with vector B will be also theta by 2. In case if I give you vector A is bigger than vector B, then the angle made by the resultant with vector A will be smaller than angle made by the resultant with vector B. So, and if vector A is of length smaller than vector B, then angle made by the resultant with vector A will be bigger than angle made by the resultant with vector B. So the resultant is going to make smaller angle with bigger vector. So resultant makes smaller angle with bigger vector. So this thing I have talked about in another class of backup only of vectors, and I have shared that link already. It is there, so you can check out vector backup number 2. Okay, but right now I'm stating all this thing as facts, but you have to prove it. And to check the proof, you can check out the recorded session of some other batch that I have said already. Okay. So name will be vector backup 2 weekdays or something. You can check out on your own. Okay.
Sir,
Okay,
can you
now.
show the previous page once?
Okay.
Thank you.
So vector A and B are equal, then the resultant will be passing through middle of them. If vector A is bigger than vector B, then the angle the resultant is making with vector A will be smaller than the angle resultant makes with the vector B. So always the resultant will make small angle with the big vector. It's like being close to more powerful guy, no? So A more powerful, so maybe I want to be closer to A more than B. So angle made with A will be smaller if A is bigger than B, and vice versa. Okay. I'll take a new page now. Next thing that we have to talk about is the dot product of two vectors. So vector is a new kind of species in mass. So because of that, how we add them and why we add them is very different, no? Addition of scalar is different from addition of vector. The meaning is different, and the process of addition is also different. So same way here, there is something called as dot product. Who defined these things? We only define these things for us. When we are doing science or physics, we found many times some quantities appearing in the same manner as the way we have defined the dot product. It's like every time table of 5 comes in use so much, so why not remember the table of 5? So same kind of thing it is. Many quantities, they come up in the same exact way as the way this dot product is defined. Okay, so you should think like as if you're doing some algorithm. Don't overthink. And what this thing is going to give us, output which is going to be a scalar output. So that's why his name is also scalar product. And the symbol we use to tell that we are doing this process of finding dot product of two vectors, we put a dot between them. Okay. And how it is defined, that I'm telling you. So dot product of A and B is defined as length of A, length of B, and cos of the angle between them. Okay. So as you can totally tell what is A length, what is this thing, modulus of B length, and cos theta, again a scalar thing. So multiplying 3 scalar, it is what really we do here. So scalar only involved. That's why dot product is totally commutative in nature. That you find A dot B or you find B dot A, both are like same only. So dot product is totally commutative in nature. Now, in case if I tell you the length of the vector A and B and angle whatever they have, then this is what we do to find the dot product. But every time it may not be like that. Suppose if you happen to know the vector A and B in terms of their components, Ax I cap, Ay j cap, Az k cap. And vector B is also given to us in terms of the components Bx I cap, By j cap, and Bz k cap. Now, there's a proof of all these things that somehow you find the length of the vector A, which we can find, no? So length of the vector A, I can totally find if I know him in terms of the components. And same length of the vector B also we can find. And if we do some math thing to find the cos of the angle between them, and I plug the length of A, length of B, and cos of the angle between them, the thing that we get is this thing, that A dot B will come out to be Ax Bx, Ay By, and plus Az Bz. So whether I use this formula or whether I use this formula, both will be giving us same outcome. But these are not two different things. Same thing only. It depends what data you have in your hand. If you know the length of A and B and you know the angle that they have, I will use this result. And if I know them in terms of their components and I don't know what is the angle they have between them, so we use this formula. So since both are same, I can equate them also. So we get length of A into B cos theta equals Ax Bx plus Ay By plus Az Bz. So I can use this thing to find cos of the angle between them also. So cos theta will be Ax Bx plus Ay By plus Az Bz divided by length of A and length of B. That too we can find out since I know them in terms of their components. That will be Ax square plus Ay square plus Az square. Bx square plus By square plus Bz square. Okay. So where you will be using it mostly is whenever I have to check whether the given vectors are perpendicular or not, or maybe I have to find angle between two vectors, then this dot product will be our first choice, because taking dot product of two vectors is like so easy thing. Just you multiply their respective components and you take this sum. So suppose if cos theta comes out to be 0, it means what? Theta is 90. So how come cos theta will become 0 only when this numerator thing is 0? So if theta is 90, dot product of two vectors will be 0. So ax bx plus ay by plus az bz will be 0. So whenever I have to check perpendicularity, dot product will be the choice that will always. Okay, so I'm just telling enough things that we can start doing physics. Okay. So just do one thing, do one simple question. Vector A is 2i cap and vector B is 2j cap. Find angle between the vector which is A plus B and A minus B. Find the angle between vector which is A plus B. So A plus B is like a new vector, and A minus B. And also, what is the angle between the diagonals of a square will be? 90 or not? So vector A and B are of equal length, no? And at what angle they are from each other? 90 degrees. So if I construct a parallelogram out of them, what will be that parallelogram will be? A square. And in a parallelogram, if two sides PQ and PS of a parallelogram, maybe I'll draw that. So this is, if I tell vector A, then this will be vector B. Then sum of these two vectors will be given by this black diagonal. And if A minus B will be given by this blue diagonal. And A and B are the sides of a square. So these diagonals must be perpendicular to each other. And that is the same thing we can find here also. So what will be the vector A plus B will be 2y cap plus 2j cap. So you see him as a new vector. Maybe I call him as vector C. And what will be the vector A minus B? I call him it as new vector D. So simple, it's going to be 2i cap minus 2j cap. Now I'm going to take dot product of C and D. So dot product of C and D will be, what is the x component they have? 2, 2. Y component they have is 2 minus 2. So you see dot product of C and D is coming out to be 0, telling us the vector C is perpendicular to the vector T. Okay, this thing is clear. And it was supposed to be coming perpendicular because we know that this PQRS is a square. So diagonals of a square, PR and SQ, must be at 90 degree only. Okay, I can take a new page.
Yes, sir.
another use of this thing can be is, so this is our vector A and this one is our vector B. And the angle they have between them is theta. So the component that vector B has along A is B cos theta. That is something we know. If I have to find component of B along A, I will just do B into cos of the angle between A and B, which is theta. So I can use it to determine this B cos theta value also. So A dot B, suppose I found out A dot B using the component thing, AX BX plus AY BY plus AZ PZ. So if I want to find B cos theta, so what I must do really is to divide A dot B with the length of the vector, And now A dot B, we know it's going to be equal to this as well. So this is going to give us B cos theta. The series is so stupid, man. If I'll find him, I'll beat him one day. AX square plus AY square plus AZ square. The same way, if I ask you, find out the component of the vector A along vector B. So from the tip of the vector A, if I drop a perpendicular along the direction of B, so this length is going to be A cos theta, and that is what is the component of A along B. Same way, A cos theta will be A dot B divided by B. And A dot B divided by B, that we can find out because A dot B is this thing. So basically, I know the vectors in terms of their components. And then my job is to find A cos theta. So A dot B divided by the length of the vector B, that too we can find since I know him in terms of its components. So Bx square plus By square plus Bz square. So this is the component of B along A. And this is the component of A along B. Okay, I hope this thing is clear to all of you. Okay, I can take a new page.
Yes, sir.
You do one simple question. Velocity vector word if I use, I hope you can understand, no? So a particle moves in the direction same as vector A, that is equal to 3i cap plus 4j cap. And its speed is 3 meters per second. Find the velocity of that vector. Find the velocity vector of that particle. So do this question, everyone. So particle is moving in the direction same as the vector A, and speed of the particle is 3 meters per second. From this data, I have to find the velocity vector of the particle.
Sir,
Just tell me.
sir, what is velocity vector, sir?
Suppose if I have a particle moving with speed 3 meters per second towards east, then velocity vector will be a vector of magnitude. So you are coming in classes, no? And then a projectile over velocity vector at least should not be a foreign thing to you. Magnitude 3, and what is the direction it is going to have? Eastward. So that will be the velocity vector. If I tell you particle, and don't ask me like what is the speed now. Speed you understand, no? Right. So
Yes,
if
sir,
I, so it means to find velocity vector, I will need what is the speed of the particle is and direction in which particle is moving. So that is given to us. So velocity vector or any vector I can write down as its magnitude into the unit vector that is in the direction of that vector. Yes, correct. And it is given the length of our vector is 3. Only thing I have to find is this v cap. And they have told our vector, velocity vector, is having same direction as vector A. So find the unit vector. In school, they are not teaching you anything at all, no, man. Which school you go to, man? That's what. More you will go to school, the more future will be ruined. Don't go to school at all. That is best thing actually, if possible. Unit vector along the direction of vector A. What we do, we take the vector and we divide him with the length of the vector. So length of the vector here, easy thing to find now because 3 square plus 4 square becomes nice 5. So vector A is of length which is equal to root over 3 square plus 4 square. That will be root 25 and that will be 5, no? So vector A is 3i cap plus 4j cap. So we divide it with 5. So we get 3 by 5 I cap plus 4 by 5 j cap. So that will be the unit vector in the direction of the vector A. So same is the unit vector in the direction of the vector which is velocity vector because they are telling us that velocity vector is in same direction as that of the direction of this vector A. So unit vector in the direction of the velocity vector and unit vector in the direction of vector A are same vector. And what is the speed given is 3. So speed will be the magnitude of the velocity vector. So length given unit vector we found out. So this vector will be 3 into this 3 by 5 I cap plus 4 by 5 j cap. So maybe you can leave it here or we can multiply them. So 9 by 5 I cap plus 12 by 5 j cap. No? Understood? No? So in class projectile running, no man. So in projectile, so many times velocity vector came. So you are understanding it, no man, or not?
Yes, sir.
Mm. Because all cannot be given as backup. That much time we don't have. So whatever chapter, so next backup will be of calculus. But till calculus backup doesn't get over, things of calculus will be in use in the class. Okay, so try to learn something like what is the meaning of differentiation is and what is the meaning of integration is, as long as we don't keep backup class for calculus. Okay, so this much vectors knowledge is enough for doing physics. Cross product I have not told because it's not going to be coming in use very soon. Whenever it will come in use there, before that I will discuss cross product in class itself. Okay, so dot product will come in use, so I have told you. Okay, so what is going to be of use is how to find sum of vectors, how to find component of a vector given to us in terms of the components, what all things I can use it, I can do from there. I can find the length of the vector, I can find angle made by the vector with every direction. And if I know vectors in terms of the components, using that also I can do vector addition. Okay. And if I know vectors in terms of the components, I can check whether the angle between them is 90 or not. And I can find dot product like that. And if I know them in terms of the components, I can find the, if I know the vector A and B in terms of their Cartesian components, I can find component of B along A, I can find component of A along B. Okay, and this example also clear. So if this much you have understood, you will be able to understand whatever, wherever we are going to use it while doing physics. Okay, then cross product is pending, so I will keep it pending because very soon we are not going to use it. So by the time whenever I will use it, I will discuss it separately in the class itself. Okay. So vectors backup over. Okay. So anyone having any doubts overall anywhere in vectors except cross product? Anyone? All of you understood now? Finding component, all of you got it. That is not an issue.
Yes.
Yes, sir.
Okay then. So okay then. So I'll share this thing and we will end the class. So next class, whenever it will be, I will tell you tomorrow. That will be of basic calculus. Okay then. Bye everyone. See you in the next class.
Bye, sir. Thank you, sir.
Thank you, sir.
sir.
Thank you, sir.
Okay, I'll end the class. Anyone not present in the first backup class, vectors, if having doubts, can ask me now. Shivani, Yogit, first vector class, you were there, no? If not there, you can check out the recorded session. Okay, then. Bye bye, everyone.
Thank you, sir.
Bye.
Yes, sir. That's it.
Bye bye, Yogit.